Hi, my name is Hashim, and this is the rail tester, cyclic rail tester that I designed. It was basically designed to test bike saddles under cyclic loads. The ISO standard was 200,000 cycles, so I designed it to be very durable and go over 200,000 cycles. This is a pneumatic cylinder, and we have mounted a S-type load cell. S-type load cell, and this is just a something to even out the surface. This is an analog displacement sensor, and it just mounts on top of the pneumatic sensor. It has a the pneumatic cylinder is sensor ready. That means it has an electromagnet on the cylinder, and this sensor is able to detect the position of the sensor. Now, the pneumatic cylinder is being controlled by the solenoids. These solenoids are in turn controlled by a relay. This is the force gauge. I'll show you the back. So this is the main unit. It contains the DAQ device. It has the relays. It has the operational amplifier, which amplifies the signal for the load cell, and then it is also and I've also installed a fan on top of it, just because there's lots of voltage regulators and buck converter in there, so just to keep things cooled down, because 200,000 cycles may be a lot. I'll show you how the front panel looks like. So I designed everything on LabVIEW, and this is how the front panel looks like. So these are the controls, and this is the tolerance. One thing I forgot to mention, that for 1,000 cycles, it detects what the average deflection was, and then based on that average deflection, it calculates to give it a tolerance, a percentage. So it's like 50%, not a standard, but just a test. And then that's how it detects the new maximum deflection. And the maximum deflection would have like a maximum, so let's say the average was 10 millimeters. The new maximum on 20% tolerance, or 0.2, would be 12 millimeters. So if it goes over 12 millimeters, it fails, and then that's it. Well, this is the number of cycles. You put in the number of cycles. You can go as much as you want. So this has to be integers. This is the maximum force that you want to test it on. So 100 kg, 200 kg. I just made it kg because it's easier. The average test we did was about 100 kg, and just tested it again and again for 200,000 cycles. This is the maximum deflection. This would change once the new maximum deflection is decided, but that would change. These are the indicators. So 100,000, this is just, it doesn't even matter, it just needs to be big enough for 1,000 cycles. And then after that, it would automatically generate the new maximum value based on the tolerances. These are the indicators. Number of cycles left, total cycles, deflection, force. This is just not working right now, but these are the indicators. So each time it passes, it's just going to go green, green, green. If it fails, it's just going to go red and then stop the cycle. So that means if you come after like a long time and see there's a red one and it stopped, that means it has failed. These are the graph. So it shows force versus deflection each time. Right now it's not mounted very properly. That's having been an issue, but I'll show you the working of it. So you just press run, check values, okay, and then continue. There we go. As you can see, the deflection sensor reads displacement, and this asks you to check torque and then fasten off the fasteners and then press continue. That's because the way we tighten it, we're not supposed to, on the ISO standard, we're not supposed to fasten it after a certain number of cycles. So I'll just press continue and then see what happens. And then press continue. So there we go. Just keep continuing. And then so you're back. So So this is the maximum deflection that's being rated. Before passing, I set the tolerance high enough. So that was it. Thank you very much.